the FY 2026 U.S. Navy context, the modern destroyer represents one of the most advanced and versatile surface combatants ever deployed, and its evolution reflects how naval warfare has shifted from traditional gun-based ship engagements to highly integrated, sensor-driven, long-range precision warfare. At the center of this capability is the modern guided missile destroyer, especially the advanced variants of the Arleigh Burke-class destroyer, which continues to serve as the backbone of American surface fleets, combining decades of proven hull design with continuous upgrades in radar, weapons, propulsion, and digital combat systems, making it not just a ship but a fully networked floating combat platform designed to dominate air, surface, and subsurface environments simultaneously. From a design perspective, the destroyer is built to achieve a delicate balance between speed, survivability, firepower, and endurance, and unlike traditional warships that focused heavily on armor, modern destroyers rely on a detect first, strike first philosophy supported by advanced sensors and long-range weapons rather than heavy physical protection. The hull form is streamlined for high-speed transoceanic travel while also incorporating reduced radar visibility features, such as angled surfaces, enclosed mast structures, and minimized external clutter, which together help reduce the ship's detectability against enemy radar systems, while the internal structure is divided into highly compartmentalized sections that improve damage control survivability in case of missile impact or underwater explosion, ensuring the vessel can continue fighting even after sustaining significant damage. One of the most important systems defining FY 2026 destroyer capability is the Aegis Combat System, which functions as the ship's central nervous system, integrating radar inputs, fire control solutions, missile guidance, and tactical decision-making into a single unified digital framework. This system allows the destroyer to track hundreds of targets simultaneously, prioritize threats in real time, and automatically assign intercept solutions, significantly reducing human reaction time in fast-moving combat scenarios. And in the latest configurations, Aegis is paired with the FY2026 radar, a highly advanced active electronically scanned array (AESA) system that offers dramatically improved sensitivity and range compared to previous generations, enabling the ship to detect stealth aircraft, low-flying cruise missiles, and even emerging hypersonic threats under challenging environmental conditions such as heavy jamming or cluttered maritime backgrounds. The radar capability of these ships is not just about seeing farther, but about seeing smarter. The FY2026 system can differentiate between actual threats and decoys, track multiple fast-moving objects simultaneously, and maintain continuous surveillance over vast ocean regions, which is critical in modern warfare where saturation attacks involving multiple missile types and drones are increasingly likely. And this sensor advantage is what allows the destroyer to act as both a defensive shield for carrier groups and an offensive strike coordinator for long-range missions, effectively serving as the eyes and brain of a naval task force. In terms of offensive capability, the destroyer's most defining feature is its vertical launching system, which consists of modular missile cells embedded deep within the ship's hull, typically numbering up to 96 in modern configurations, and this system provides extraordinary flexibility because each cell can be loaded with different types of missiles depending on mission requirements. For example, standard missile variants such as SM-2 and SM-6 are used for air defense and long-range interception, while Tomahawk cruise missiles allow the ship to strike land-based targets hundreds or even thousands of kilometers away with high precision. And specialized anti-submarine rockets extend its reach into underwater warfare, meaning a single destroyer can perform multiple mission types without needing reconfiguration at sea. This multi-role flexibility is one of the key reasons destroyers are considered indispensable, because they are not limited to a single battlefield role but instead act as adaptable platforms that can shift between offensive strike, defensive escort, surveillance, and anti-submarine operations depending on strategic needs, and this adaptability becomes even more important in FY 2026 scenarios where naval conflicts are expected to involve highly unpredictable combinations of missile attacks, drone swarms, submarine threats, and electronic warfare interference. Below the surface and beyond the horizon, the destroyer's anti-submarine warfare systems play a critical role in ensuring fleet safety, as modern submarines represent one of the most dangerous threats to surface fleets due to their stealth and long-range strike capabilities. To counter this, destroyers are equipped with hull-mounted sonar arrays that actively and passively listen for underwater threats, as well as towed array sonar systems that extend detection range far behind the ship, and these sensors are often complemented by embarked helicopters such as the MH-60R Seahawk, which can deploy sonobuoys, torpedoes, and additional sensors far from the ship, effectively turning the destroyer into a mobile anti-submarine warfare hub capable of controlling vast underwater search zones. Propulsion is another critical aspect of destroyer performance. In modern U.S. Navy destroyers rely on gas turbine engines, typically the General Electric LM-2500 series, which provide a combination of high power output and operational flexibility, allowing ships to reach speeds exceeding 30 knots while also maintaining the ability to operate efficiently over long distances. Unlike older steam-powered vessels, these engines can be started and stopped relatively quickly, which enhances operational readiness and reduces maintenance complexity, and when combined with advanced power distribution systems, they allow the ship to support not only propulsion but also increasingly power-hungry systems like advanced radar and future directed energy weapons. From a crew and operations standpoint, a modern destroyer typically houses around 280 to 300 sailors, and while this may seem large, it is actually relatively small considering the complexity and scale of the systems onboard, which is made possible through heavy automation and digital integration that reduces manual workloads and allows personnel to focus on system monitoring, tactical decision-making, and maintenance rather than purely mechanical operations. Life aboard these ships is highly structured, with crews operating in shifts around the clock to maintain continuous readiness, and while conditions are more comfortable than older naval vessels, space remains limited, requiring efficient use of living quarters and shared facilities. The destroyer is also a key node in what is known as network-centric warfare, meaning it does not operate in isolation but instead functions as part of a larger, interconnected battle network that includes satellites, airborne surveillance platforms, submarines, aircraft, and other surface vessels, all sharing real-time data through secure communication systems. This allows a destroyer to detect a threat using one sensor, track it using another platform, and engage it using a third, creating a highly distributed combat system that is far more resilient and effective than standalone ship operations, and in FY2026 environments, this connectivity is essential for countering fast-evolving threats such as hypersonic weapons and coordinated multi-domain attacks. Electronic warfare capabilities further enhance the destroyer's survivability and offensive flexibility, as modern systems can jam enemy radar, disrupt missile guidance systems, and create false targets to confuse adversaries, effectively reducing the accuracy and effectiveness of incoming attacks, while also allowing the ship to operate more freely in contested electromagnetic environments where control of the spectrum is as important as control of physical space. These systems are constantly evolving as adversaries develop more advanced detection and targeting technologies, leading to an ongoing technological competition in electronic warfare dominance. Looking at survivability, modern destroyers are designed with layered defensive systems that combine hard-kill interceptors, such as missiles that physically destroy incoming threats, with soft-kill measures like electronic jamming and decoys, ensuring multiple opportunities to defeat an attack before it reaches the ship, and the internal structure is reinforced with redundant systems so that even if one section is damaged, others can continue functioning, which is critical in combat scenarios where missile impacts or underwater explosions can cause localized but severe damage. When considering the broader strategic role, these destroyers are essential for protecting aircraft carriers